Okay, hello everyone. Okay, welcome all to our today's TAQELAH webinar. Today we have Kenneth Poon, who is the Principal Software Engineer at SP Digital. And Kenneth is going to talk about API contract and localhost. Okay, hello everyone.
Can I start?
Sorry, Kenneth. There was some problem with the So Kenneth is a Principal Software Engineer at SP Digital, and he's going to talk about API contract and localhost UI tests today. So over to you, Kenneth.
Okay, thank you everybody for attending this talk hosted by the TAQELAH team. The topic today, app development, mobile app development integration test, introducing API contract and localhost UI test. My name is Kenneth, and here is my profile. Feel free to reach out to me if you have any questions after this talk. Here's also my GitHub, Medium, and LinkedIn profile. About me, I'm a principal software engineer at SP Digital. Just to share, SP Digital is the digital arm of SP Group, which runs and manages the transmission of energy, managing the energy grids for the Republic of Singapore. And I like to bring agile development into the iOS space. And I'm also a regular Tech Talk contributor in the iOS Dev Scout meetup group in Singapore. So here are just to share a bit about myself. Here are some of my testing related talks I've given so far. I've contributed to the iOS Dev Scout, iOS Conference SG, Agile Singapore meetup, and the mobile conference in Bangkok. And most of my test related talks over here are centered around iOS development. And I have also contributed iOS development talks. More interestingly about hacking. So back in 2016, I gave a talk on how you can actually write code to hack the Pokemon Go on iOS. So if anybody is interested to explore the topic of iOS exploits, feel free to drop me an email and catch up. You can catch up with me after today's talk. So the topic for today is focusing on integration tests for mobile development. In my current and past experience, I've introduced localhost UI test as well as API contract test to help give me fast feedback on my development. So I will share my experiences and observations on test-related issues that are common in the development and testing phase leading up to app releases. For localhost UI test, I will be showcasing an iOS library that I wrote, Swift localhost, describing how you can easily set up in-memory based mock server in your Xcode for executing UI test. I will also share how contract tests can be useful in getting fast feedback. For this segment, I will be sharing a very simple Ruby library called Cucumber API. So just a disclaimer, this talk will just be focusing on the integration test process. I will be using these tools as an example to show how it can bring value to your work. After this talk, you may want to look at your existing tools and revisit them and consider how you can build the same type of integration test on top of them. So for me, I started my career in 2008. I was a J2E developer and later picked up iOS development. There's not much iOS tests and CI practices out there, but I am passionate about agile development and extreme programming. I saw an opportunity to differentiate myself, and I went deep into the iOS space. During my earlier days of UI test automation, I used Calabash as cross-platform automation tool, Sinatra to create my mock server, and Cucumber for writing my contract test. Later, I went deep into Swift, and using my previous automation experiences, I am able to bring BDD Gherkin, behavior-driven development, into iOS, and created a library called Swift localhost. Cool. So in my presentation today, I'm going to use 3 personas to help deliver my content. So the first persona is the mobile developer. Hello, everybody. I'm a mobile developer. In terms of testing, I write unit tests to ensure that my modules are working as expected. I will also ensure that I achieve high code coverage for my native codes. The second persona is QA. Hi, I'm a QA engineer. I take ownership of mobile end-to-end test. When the mobile app build is ready, I will verify it in our test or QA environment. And the third persona is the back-end engineer. Hi, I'm a back-end engineer. I write tests that cover the behavior of the services I build. So these are the 3 personas I'll be referencing, and their journeys are based on issues I observed that happened during the QA testing phases leading up to app release. These personas are not meant to generalize how everybody is working. So these are just my observations I have noticed at my workplace. So first off, one example, just to share an example of how the problems I noticed at work. Here we have a mobile developer, and we want to build a new feature on the app. This feature requires a new API service. So we go ahead and approach the backend engineer. So the backend engineer tells us, hey, he would need to build a new API service for us. But at this point of time, the API is not ready. So he draws up a document that states the API contract. This contract will be used to bind the execution of the native app code with how the API services will be consumed. Meanwhile, we can use this contract to develop our mobile front-end features. When the API is deployed, we are ready to release our app. So everything works well when we deploy the first version of our feature. But as time passes, new changes on the API services is introduced. Sometimes the new changes may inevitably break the app. And here the QA appears. Hey, what's happening? So the app breaks because there's a change in the API contract, which is not compatible with the mobile app. The contract definition has changed. Sometimes it's because sometimes the back engineer may not be aware of what services the application is consuming. He may be considering some refactoring, but the API service has a lot of clients, so he may not know whether all of the clients are actually consuming particular services. And something I noticed that QA only finds out changes in the API contract after running the test, after running her test suite. So the mobile app usually relies on a few things: API service, database, and sometimes third-party services. When any of these dependencies fail, this will cause a problem on the app. And when it happens, our QA friend appears again. Hey, my end-to-end test failed again. What is happening this time? The app is breaking because some of the dependencies are down, and that makes the app very brittle. And sometimes the test data fixtures are not properly synced up. For example, certain credentials are not there, so are not available in the environment. So when certain test cases are run, it will cause it to fail. And the same reason as before, engineers may only discover broken dependencies after they run end-to-end test. So here's a conversation between the mobile developer and the QA. Hey Dev, the app is breaking very often in test and staging environment. Sorry about it, QA. My native code is working fine. It seems like the backend services are down at the moment. Grr. It took me an hour of test execution just to discover that. This is driving me crazy. I know, another time backend engineer unknowingly changed the API schema. I understand, but I will always find you first whenever I discover any of these issues. Okay, let me come up with a solution for this. About end-to-end test. As QA, we own and take a responsibility in the development and maintenance of the mobile end-to-end test. But end-to-end tests are very brittle. The mobile apps typically have multiple dependencies. We need to ensure all dependencies, such as the server, the database instance, third-party services, are properly set up before we run the test. And it is also difficult to write tests that are dependent on shared resources, because this will actually lead to race conditions, repeatability issues. For example, if we want to rerun tests that registers a new customer, we have an existing username, usually that will cause you'll meet into problems, because especially when the username already existed. And end-to-end tests are generally slow and expensive. So even if we can write end-to-end tests, we may not be able to achieve comprehensive UI automation test coverage. So let's look at mobile testing using the test pyramid. At the top of the pyramid, we have the end-to-end test. At the middle layer, we have integration test. And at the bottom of the pyramid, we have unit test. For most mobile development setup, we will be using XC test, JUnit for unit test. At the top of the pyramid, we'll be using end-to-end tests like XC UITests or APM. And here I'd like to recommend two categories of integration test: API contract test and mock response test. So the general setup for mobile app is the app and its interaction with a server. For API contract test, we will mock the app and test the API interaction against the server. One example, we can run a series of HTTP requests, fire it to the server and assert that the server is working as expected. This kind of test usually checks the schema and sometimes the data, the response. If the API contract test fails, there's no point running our end-to-end test. Failure in the contract test has proven a point that something in the backend systems or environment is not working as expected. For mock response test, we're going to flip it around. We will mock the server and its dependencies and assert how the app behaves. One way to set up mock response test is to use localhost, where we basically create a web server in the test runner. So here I'll be showcasing localhost on XC UITests in the iOS development environment. I'll be showcasing all of you a library that I wrote, Swift localhost. So just to take note, for the steps I'm going to share, you can actually implement it if you are doing your Android development setup, or even if you're doing it on the APM level, the end-to-end test level, you can actually write inline mock servers. So here is the guide to set up localhost that I'll be sharing with all of you. So there are 4 steps to set up: L, A, I, and M. So the first letter is L, localhost. We're going to set up in-memory localhost server. The next letter A, we're going to redirect calls, all the outgoing calls to the localhost server. And I, for just particularly for iOS environment, we need to the Info.plist to change some of the build configurations. And lastly, M to set up the mock responses. So let's start with the first letter, L, that is localhost. We're going to set up an in-memory server in the test runner. We have to assign a unique port number to the localhost server so that we can run our test in parallel. And then we will set up and tear down the localhost server when we execute each test. So this example in the iOS code in Swift. Firstly, we import Swift localhost library, and then we create an instance of localhost server. And in our setup method, we're going to initialize the localhost server with a port number, and then we'll tell the server to start listening. In the teardown, we're going to tell the server to stop listening. So here we are using a fixed port number, which may not be ideal. It prevents us from running our test in parallel. What we want to do is to assign a unique port number for each test case so that we can run, so that each test, the mocking of each test will not be interrupting the other test. So we're going to use this function, initiate using random port number, to assign the next available port number for use. Next is A stands for API. We're going to redirect our existing outgoing API calls to hit the localhost server. Just a simple example. In our code base, instead of hitting this API, this domain API dot the moviedb.org, we're going to change it to localhost assigned with the port number. To the next step, we need to do a little change for iOS on the Info.plist. Here we need to configure some exceptions so that the system will allow firing of HTTP requests. Because in Xcode, by default, you can only fire out HTTPS requests. So here we have to update the Info.plist to allow that exception. And lastly, after LAI is the letter M. We're going to mock the responses. So we are going to set up the mock responses based on the API being used in the test case. So here, when the user tries to log in, we're going to return the successful login JSON. And when the app tries to fetch the list of movies, our app server is going to return a list of JSON describing the movies. So this is an example how mock response setup may look like. In our test functions, where we have our test codes, using the localhost server, we'll call the route function and specify whenever it gets a GET request of the path 3 movie popular, we are going to return the contents of this JSON file home popular. And that's it. We are all ready to use LAIM to set up our very own localhost based test. But here we can actually go further. Here we can actually accept localhost request. So let's assume we want to describe a use case for bookmarking an item on a shopping app. In our hypothetical use case, we're going to start off on the listing view. Here the app fires a request to fetch items to load on a table view. When we select a row, we will navigate to the details page. And upon screen load, the app fires another request to fetch detailed information on the selected item. And on this screen, the user can tap the heart icon, and the app will fire another request to bookmark the item. So in this use case, we expect 3 requests fired from the app and to be received by the localhost server. We can use a Swift localhost library to write tests to make sure the requests are being fired in this particular order, no more, no less. So this is a snippet of the localhost server definition. It has a property called recorded request that records all the request objects that are being fired from the HTTP request objects. So in our test, we're going to inspect this variable to set up our assertion statements. So firstly, we can specify and set the order of the request by the URL path being used in our test. Why we only care about URL path? Remember, we have changed all the domains for outgoing API calls. Instead of hitting the production APIs, we're going to hit the localhost domain. And then, here we have an array of strings of this path of 3 movie popular, second item verify password, third item get account info. And then we're going to get the actual recorded request path from the localhost server object. And then we assert that both paths, expected and actual paths, are the same. We can also represent the request as curl commands. Curl commands are, you can actually copy each line item into your terminal or into your shell, and you can actually run them to make an actual HTTP call to your API service. So here are the expected curl strings. And then again, we get the request objects from the localhost server, and then we assert that the expected and actual strings, or rather the actual expected and actual request are the same. Okay, next, so here I will be showcasing, showing a demo of Swift localhost in iOS. Just take note of how I actually write the codes, where I actually set up the localhost server, how I set up the mock responses. You may want to try this out in Android or even in APM. So what I did for this demo is I actually find a project that on GitHub, just a random project that doesn't have test. And then I asked the author, can I actually use that for my talks? And he agreed. So I'm using this as an opportunity to show everybody that you can actually easily write tests on a project that doesn't have any test. Now I escape. I now go to my Xcode. So firstly, I would like to show all of you what this app is about. So let me run the application. So this is a movie app. So the first thing that the app does is to actually fetch the list of movies. So I'm going to my console, and this is the URL. Sorry. So this is the request that's being sent out by the app. So I copy this request and I go to my Postman. So this request is hitting the movie DB org of the path 3 movie popular. So this gives you returns you a whole list of movies. The first item is Ad Astra. Second item is Eurovision Song Contest. And this Ad Astra and Eurovision. And next, I tap on, let me clear the console first. When I tap on a movie poster, let's try this, Hamilton. I'll be taken to the movie detail screen. So this is the, okay, let me copy this to Postman. So this is how the HTTP request for getting movie details look like. We actually put the movie ID, append the movie ID into the request over here. And then you can see the overview of the movie presenting the tale of American founder Alexander Hamilton. And that is displayed over here. Okay. So it's a very simple movies app. And I add on an additional feature. Here I like to do a simple login and authentication. So I tap on login and I attempt to register a new user. So I'm using Firebase authentication, so it doesn't really matter whether the email is a valid one or not. So I'm going to say the TAQELAH1@gmail.com. And the password, I'll be using password1. And now hit register. So this will fire a registration request to Firebase. And let's inspect the curl command. So this is the curl HTTP request that is fired to Firebase, which is of the domain googleaps.com. So let me play this on Postman. So here I get a bad request because the email has already been it's already existed, and what I just did was to just replay the request. So let's change the body. I changed from TAQELAH1 to TAQELAH2. I send. And now I have a successful status 200 response. And this is the response that I get. Okay. So here, let me try to log in. So login TAQELAH1@gmail.com and password 1. So let me clear the console. Yes, we're now able to log in. And let me check the console. Check for this guy. Okay, so we have the first request that's been fired by the app. Let me put it into. So this is actually, if you look at the body, we're actually sending the email and password over to Firebase authentication. And here we get the ID token. And the next API that is being fired after logging in is get account information. Okay, so what we did was to, let's go to the header. We pass in, we pass in the ID token that we received from the login API over to this API to get some information about the user. Okay, so this was happening when we run the app. So as you can see, we have the different APIs and the responses. And what we can do for localhost testing is, instead of, we now have all the response. All we have to do is just make sure that our app, instead of hitting this production API, change all this to localhost. So we have the list of movies, we have the movies detail, we have signing up a new user. We don't really care what the data is, actually, or rather, we don't really care what you send. For the purpose, depends on your test case. If you just want to always have a successful login, then it doesn't really matter what you send. All you have to do is return this status 200 request and JSON response. And then after login, there is two things required by Firebase authentication, which is verify password and get account info. So now let's move on to the test. So based on my talk, the 4 steps are LAIM. L stands for localhost. So let me go to the simpler test here. Okay, login test. Go to the top. So the first thing to do is to set up the localhost, import this library, and then in your test class, create a property called localhost server. In the setup, just initialize, but here remember to assign a random port number. If you don't intend to run your test in parallel, then assigning with a fixed port number should be okay. And so we're going to start listening when we in the setup, and the teardown, we're going to stop listening. Okay, for this test case, so after L, the next letter is A, and A stands for API. So in our the production API is actually API.themoviedb, so which is over here. So I'm going to make amendments when we run the test. So instead of hitting this domain, we're going to hit localhost with the port value provided by our test runner. Localhost with the port number. After LA, the next letter is I. And I stands for Info.plist. This is only required for, sorry, not this one. This is actually only required for iOS development. We need to add an exception configuration over here so that we can hit localhost. After I, then the last letter is M, which stands for mock response. In our test, firstly, we're going to this is the use case. We're going to go straight to login and type in our email and password, and we should get a successful login. So the first thing when we start the app will automatically hit 3 movie popular. So that's one. So when it hits this API, this path, we're going to make sure that we return the response home popular. And home popular is over here. It's exactly the same schema, the same schema, just maybe the older values of how the list of movies will look like. So just take note, the first poster you'll see is Fantastic Beast. And the second poster will be Mission Impossible. Now let me return to my login test. Okay, so after going after seeing the list of movies, we're going to tap the button on the top right corner, which is to log in. So hitting on login will just show the login screen. It won't hit the API. So we're going to type in our email and password, and we are going to hit the verify password API call and the get account info. So these two information, this part of this login can be quite tricky because for some of your client apps, you actually use a library to actually hit the APIs. You may not know the path, so it's not impossible. I have a library that actually allows us to intercept requests and to find out all these paths, but I won't be covering that in this topic. So as you can see what we have gone through earlier on, we know that we will be hitting verify password and get account info. So with that, when we hit this API, for these two cases is a post method. We're going to return verify password and get account info JSON. So for the rest of the test case, it's all about coming in, typing some arbitrary email value, password value, doesn't matter whether it's valid in production. And when we hit the login button, we should be able to see the login success pop up. Yeah. Okay. And the second part is we can actually assert the request that's been filed in a particular order. Why this is useful? Because we want to know that how this will actually help us to. Okay, most of the time this may not be really applicable, but this can be very important to ensure that the app is firing certain sequence of requests to the server. So if this is helpful, you may want to try this out in your test. So here we want to make sure that we hit you get the list of popular movies, and then we hit verify password and get account info. Yeah. So I'll be running a test. A second test I'll be running is about movie details. The same thing. We hit the movie, and then we will be navigating to upcoming, and then we hit this particular movie ID. Get the movie details based on this movie ID, and then and then we make sure that the request pass this request pass. So now I'll just proceed to run the test. So just take note of the movie poster. The first one is about something about the beast. The second one is Mission Impossible. Crime solve something, Mission Impossible. So the first test passed. Second test I'll be running just to get to the detail screen, movie detail screen. Yep, and there you go. The test passed. So if you have any questions regarding how things work for the localhost test, feel free to ask me at the end of my talk. So now I'll just return back to my slides. So some FAQs on localhost UITests. So this has been asked previously by some developers. Hey, why can't we just add the start responses in the code instead of having a localhost to mock the response? So some developers write UI tests by setting mock response within their production code. So when a use case required network is triggered, actual code execution only reaches the mock response and returns it back to the client. So, but this neglects the other layers in the app, like the HTTP layer and the TCP layer. So such test does not correctly reflect how the app behaves in actual production. If you're writing tests this way, this is not really recommended. So localhost test, on the other hand, ensures that the code on all layers are executed for the network request to complete the use case. So what are another question, what are the advantages of using Swift localhost or other localhost web server solutions? So here we have Swift localhost, and then we have other web technology mock servers. So here are the advantages. Firstly, for Swift localhost is easy because it's based on Swift. You can easily install via CocoaPods. You can use Swift to set up the mock server. You don't really need to create a separate instance using a different technology, assigning a different IP, and then you need to maybe create a domain in your subnet, and then put it into there's a lot of coupling between the actual mock server and the test codes. So here you can actually inline the mock responses in the same test code, which is very, very useful. That is good because each test has its own mock responses and you can manage them independently between each test. And for Swift localhost, we're using the same runtime Xcode debugger. It's useful. And all you have to do is just run, actually not control, it's actually command U to actually simply run the test. Everything's done in the same ID itself. Otherwise, you need to, even if you're creating a localhost server on the same Mac, same computer, same laptop, you still need to go to the terminal, run a command to start up your server. There's a lot of external things you need to work with. So that is that can add a lot of overheads. So how does localhost UI test technique fit my development process? Cool. Let's revisit the shopping app bookmarking use case. Firstly, we navigate to the list view. We fetch a list of items. Here we have a JSON response. We tap on the first item, we navigate to the detail view. Fetch the item detail view using the detail API. We have a second response. And then we bookmark the item. We hit the bookmark API, we get another response. And then we assert that the bookmark icon is correctly reflected. So here are the three responses that we collect based on this test case. So the benefit of this test case, you can use it early in development. Knowing what the contract is, you can already set up the mock responses and to write the test case. The good thing about localhost UI test is this test case will never fail because it's totally decoupled from the dependencies. That's the cool thing about it. However, this will never fail provided the environment doesn't change. If the environment change, then all of your mock responses may give you false positive. So here comes to the next part of my talk, which is the API contract test. So let's bring out our friends, mobile developer and QA. Hey Dev, I know it's great that you have mock response tests or your local UI tests, and they never fail. But the APIs do change, and the changes might break the app. Yes, QA, you are absolutely right. But our app releases are bounded by pre-agreed API contracts. We can write the script to ensure that the APIs are working as agreed upon. We can use this script to discover which services are breaking the app. So here for the API contract, let's say we have this API contract has it assets 4 API calls: login, shopping list, product details, and each of them has a schema. So we know the API contract. We can file the request hitting these specific endpoints. The first version of API, of course, it matches because we wrote the contract based on whatever we consumed. When there's a new version of API, let's say version 1.1, for example, the backend developer adds in a new API call or new key, but it doesn't break the app. So everything's good. But when there's a breaking change on the API, for example, V2, where the product details API changes from the schema changes from version 1 and version 2, the app breaks. So we know the app at this time will break because it's unable to recognize the change in the response schema. So here is our mobile developer. Gotcha. Latest API deployment broke our app. So here's our backend engineer. Hey, mobile dev, why are you writing tests against my API? Shouldn't I be the one responsible for that? Our app will perform correctly only when dependent services are working as expected. Our API contract test will give you quick feedback whenever deployed services break the contracts. Mobile developers will be responsible to maintain tests that describe the services the app consumes. Okay, that sounds awesome to me. You know what? I think we should automatically trigger the API contract test every time we deploy any changes. Nice. This encourages backend developers to deploy changes without worrying whether it affects the mobile app clients, because we will catch any breaking changes. So for API contract tests, the purpose is to write tests only for the services, the response keys that are consumed by the mobile app. It's not to write tests for all the services, all the responses are provided by the backend services. And here's QA. Dev, I feel annoyed that after running my test, I discover my test fixtures are not ready or incorrect. For example, the login credentials are not properly based on the end-to-end test are not available. The product details on staging environment are not correct. So your test cases actually describe the request and response exchange that will be expected. We can write API contract tests that change the order of API requests that simulates a use case on the app. You can simply run the API contract test before any automated or even manual testing execution of the test. This will give you a heads up whether your test will fail. And since API contract tests are generally fast, you will get your feedback in no time. Wow, this sounds awesome. I'm eager to have a go at it. API contract tests are generally fast. The best thing about it, because these are just HTTP requests, you can actually run all of your tests, if possible, in parallel, and that will actually give you your results in seconds. And here I would like to introduce just a very simple do a demo using a Cucumber API. So Cucumber API is a Ruby library that it's based off the Cucumber framework, and here it's written in like given when then BDD format. So what we can use this for is to describe how we describe the API request that will hit the server, and then we can check that the response matches the schema that we expect it to be. So in our case, when we fetch a popular movies, we're going to hit this API. I remember back in our Postman, this is the first one over here. The exact request they're going to send to the server is this plus in the GET request, the API key and the page number. So here we're going to fire to the same thing, hitting the production API. Of course, in your course of work, you might want to configure this to the test server or the staging server. And we're going to pass these two values of API key, the value, and the page number of 1. And we're going to ensure that the response matches this schema. This is the JSON schema. So let me pull this up. So we have page, response key of page, total results, total results, total pages, and then we have a results key which has an array of movies, and there's keys like vote count, popularity, and ID. So here this is the JSON schema. We expect of page to be of type integer. We expect total results, total pages, and in the results array, we expect the movie object to have vote count, ID, popularity amongst the other properties in the movie details. So here we can actually, based on how the app is firing, we can actually do the same, hitting popular. That's for one test case, and then here hitting upcoming, and then because both expects the same schema, we're going to use the same schema to check against the response. So for the movie details, what we will do, we'll be hitting the popular API. And in the response, we're going to pick the first ID, set it as a variable movie ID. Using this, we're going to hit the movies detail API, where we append the movie ID at the end of the request. And then we expect the response to match this JSON schema, movie details. So this is a very simple setup. I'm just going to show you how to run. So to run it, after setting up the feature files, you just run Cucumber, and this will hit all the different APIs. I basically have only here. This is a very, very naive, simple test, but I think you get the point that hitting the API, you can actually not only check the schema, you can also check the value. So I created this post feature file where I just sent this payload, this post body to this API, and I'll be receiving a response of ID title with the response keys ID, title, and color. And here is an example. I expect the JSON response should have a key of ID, integer, and value 101. And this is, I mean, I did not show you what the request and response looks like, but I think this is how you actually describe. And there are various ways to describe interaction with the response and the request. So I would recommend you to try this out. But then again, you don't really need to just stick to this library. You can actually use Postman to create collection tests and run it as contract tests. You're familiar with PHP or Node.js, you can actually write your own scripting to verify your API services. So the idea is, what we want to do is to run some HTTP request and response exchange and check that everything's working fine. In fact, before we run our test, you can actually map that to the actual test case you're going to run. So that's it for the Cucumber demo. I'll return back to my slides. So here, I'm going to ask our three friends, our three personas, what is your take on API contract test? So for the mobile developer, API contract test checks whether our app dependencies are working as expected. The contract definition aids us in designing our localhost test. For the QA, API contract test is a cheap and fast way for QA to ensure that all dependencies, including data fixtures, are ready before we start testing. The fast feedback saves us time, especially when we can get feedback within seconds. For the backend engineer, with API contract test, I have more confidence to refactor my code base. We are now encouraged to run API contract tests tied to the released app versions and check if older versions will be broken by new API code deployments. So on this note, one good way is if you have your own API contract test in your native app code, you can actually check out all the tag versions of previous releases. For example, for Android app code base, for the past few releases, check out all the tags and run the API contract test against the new backend codes. This is one good way to actually check which previous versions will break if we deploy the new code to production. So here's my closing. So integration tests are meant to complement, but not replace end-to-end tests. We can confidently run localhost tests to verify that the native app code is working under normal, valid conditions. So do consider having both mock response and API contract test. API contract test for this talk is the low-hanging fruit. you can actually use any language. You can go back and start writing them. If you want, you can actually explore using Postman, because Postman has a test runner. You can actually hook up to Jenkins. What you want is to be able to declare, to specify the request response exchange, and you get your results in seconds. Sometimes it may be difficult, but not impossible, to actually mock services used by third-party libraries. So this is something where you need to explore with your mobile developers how can you actually intercept the request. Even like, for example, even though you're applying SSL pinning, it's possible to add in certain codes in your code base, native code base, to actually intercept the requests for the purpose of building your test. So do visit your existing tools and see how you can bring integration tests into your development. So these are some references in my slides. The slides for this talk. Oops, sorry. Anyway, so questions. Abi, hand over to you, Abi.
Hey, Kenneth. Yes. So we have a few questions, and we also have some time to take those questions. So the first question, I have shared it with you. Can you see that?
Yes.
Yeah.
So the first question is, actually, why don't I do this for everybody? I'll post it on Sublime so that everyone can see. So have you implemented this test automation strategy as part of your regular sprint development work? When do you run this test? Is it only locally or also on the CI? So this is usually when I would consume, if my sprint development only requires local native code development, then of course there's nothing I need to do. When I feel the need, whenever I consume new services or take note of new keys in the response that I need to use, I feel the need to actually add it into the contract test. You need to, I think the first off, it's not easy to convince people that, hey, not many people are, this concept of contract test is not new, but some people need time to actually absorb why we need to do this. So for me, I would actually create a task in the sprint, subtask, and just to make sure that I add the key into the contract test. If you're just going to add one key into the definition of the JSON schema, then it's not really a big effort. But if the use case is pretty long, then of course it will take some time. So I would encourage people to actually do that, because it saves time in the long run. It may not save time immediately, but when you have a very complex flow, for example, you need to do some shopping on the app where your flow is spread across different screens, hitting different APIs. You do not want to come back 3 months later to realize, oh shucks, did I break anything? If the backend guys want to make changes, they may not have a lot of confidence. They will tell you, hey, can you rerun your test? It's easier if you have your contract test. Do we run this locally or also on CI? So there are two parts. There's a local one and there's a CI. So there's, sorry about it. You should also run locally and on CI. Locally, you can actually quickly check whether things are working. When you only have the contract definitions, then you can use that to drive your code. So you can actually, that's one way I do it at work. I actually define it as BDD. So I write a given when you have this, given that when I hit this server endpoint, I receive this mock response. I should be able to run my UI. So I do this locally as well. So the second question is, let me paste it over here. What's the total time execution of this test? Will it impact the total build time added to the build pipeline? So contract test is within seconds, depending on whether the test is conflicting with each other, will affect each other, will affect the total build time added to the build pipeline. It will, because you are running additional layers of test. Then again, depending on your use case, I will not say that integration test is a must to do, because if you already have a solid comprehensive end-to-end test, that'd be great. It will definitely impact the total build time. But think about it. Some end-to-end tests are very difficult to write because it's the nature of how you build the software that you have certain check and balances. You cannot add re-register a user with an existing username unless you deleted it off in the database or you kick the user out. So sometimes we want to mock certain things around our app so that we can test certain specifics. For example, we might want to disable some security features so that you can run certain tests. So these are all at the integration level. Any other questions? Okay. Okay, so the next question, does the Swift localhost UI test only support text-based response? How about responses which are encrypted in other formats, just like binary or media? Does it support them as well? The library itself is, as of now, only supports text-based. It is possible. We would need to contribute more to support binary and media format. So it is possible. If you think about it, it's just running certain Swift code. So if in the app, because we are using Swift, which is the same language in both the application and test, we can actually assert that whatever binary that you're building out from or creating in the app production code, we can actually do that in the test. But as of now, it's not supported, and yeah, take note and add it in for future features. Yeah. So then next question. With the local UI test, is it possible to test features like payments that use third-party APIs? Yes. In fact, what I've shown you in my code base is, maybe I can show you. Is the login. So here, login view controller, we are using file-based authentication. So in this code base, we don't know the APIs. We don't know the APIs. So there's some investigation needed to actually uncover what is the API that's hitting this server. For things like payments, it can be quite tricky because sometimes you will be given a web page where you need to put in your one-time token. So things like that you will need to mock. It's not impossible, but it really depends on how the complications of the third-party services. But if it's just simple API calls hitting like Google, hitting Firebase, number one, you need to actually know how to get those URLs. So just for Swift, because I did a lot of investigative work, I actually wrote a blog post over here. How you can actually intercept your request into Postman. What the library does, maybe just a 1 minute sharing. What I did was to actually intercept all requests that goes out of the system and create a curl command out of it. So along the way, if you use this technique right, you can actually also see this third-party API calls that been fired from the app, which you have with the audience today have seen it just now at the demo. The next questions. Wow, so long. For responses which are dynamic, let's say a field that involves date time in the response, it's possible to build the responses dynamically using localhost UI. Can we mix and match between hitting actual server and localhost with the same UI test suite for different purpose? So let me split this into two. Possible to build the responses dynamically using the localhost UI. Yes. Let me return to the code. So in the login test, it is possible to, well, at this point of time, it's not supported, but it's a trivial thing to actually extend this behavior. So what can be done? So this is actually getting a data object. It's a binary object. And I'm using for here, I'm using a factory that reads a file and convert it into a binary object. So you can actually replace this with your custom binary. If you can actually do that in your UI test. So this is actually you need to find out how to actually create this. But yes, this is supported at the moment. Can we mix and match actual hitting? Yes, you can. So in this code base, what I've done is I have one main URL that's hitting one main domain that's used across all API calls. It is possible to do that. You just have to do some manual configuration in your production code to choose which ones hit the local host and which one don't hit. So it's possible. And then we did the same UI test for different requests. Yep, I think I answered that. Any other questions, Abi? So possible to distribute the localhost UI test on multiple simulators at the same time to test simultaneous communications like chat. So the first part of it, can you distribute across local multiple simulators? Yes, Xcode provided if you use the XC test test suite in Xcode. So this localhost Swift library uses that. Yes, you can actually have it on multiple simulators. To test, so for this is to run multiple tests across this, to load multiple simulators and farm the test to these simulators. Yes, you can. For the second part, simultaneous communication like chat. If you're saying to launch two different, to launch a test where you have two different simulators talking to each other, this is something I'm not sure because I've not tried that before. So I am unable to I do not know how to do this. Yeah. Done with questions. Okay. Thank you very much. If you have any other questions, just feel free to drop me an email. Just let me bring up my slides over here. Yeah, drop me an email at dpoon@hotmail.com, or just reach out to the TAQELAH team. So I'll hand it back over to Abi.
Yes, thank you, Kenneth. This was really an insightful session. We learned a lot about testing iOS integration using localhost UI, as well as the API contract testing. So I think this is all for today's webinar. And thank you all for joining this session. I hope it was quite interesting and learning for you as well. So yeah, thank you all.
Thank you.